All right, in this example, we're going to take a look and see if a function is continuous at -3, this piecewise function that we're taking a look at here. Again, this is just a matter of checking the three conditions for continuity. So the very first thing we want to take a look at is f of -3 defined? Is -3 in the domain of this function f? So I would look at these conditions here and find the one that -3 satisfies. -3 is equal to -3, right? And so therefore we would plug it -3 into this function, but since there's no place to plug it in, it's just equal to 4 here. But condition 1 for continuity is satisfied. F of -3 is equal to 4. Okay, next up we move on to condition 2. Condition 2 is, does the two-sided limit as x goes to -3 of f of x exist? So if you looked at the previous example, in the previous example we could kind of get the two-sided limit all in one shot because of the way that the conditions were defined here. But in this one, for the two-sided limit, if you'll notice, right, if we're approaching 3 from the left, or -3 from the left, we would be less than -3, and so therefore we would be using this condition right here. On the other hand, if we were over to the right of -3, so if we were taking the limit from the right, we would be using this formula here, which is a totally different formula, right, than it is over on the left-hand side. So because the formula on the left side of -3 is totally different from this formula on the right side of -3, we have no choice but to look at the two one-sided limits individually and then try and get the two-sided limit based on what the two one-sided limits are equal to. Okay? So first, let's take a look at the limit as x goes to -3 from the left. Right? If I'm approaching -3 from the left side on the number line, right, those values of x would be less than -3. Okay, and so therefore I would be using this formula right here to find that limit. The limit as x goes to -3 from the left of 2x plus 3. If I substitute the -3 in for x, I get that expression, which turns out to be -3. So at least we know that the limit as x goes to -3 from the left of f of x exists, and it's -3. All right, but we really want the two-sided limit, so what we're going to have to do is to take a look at the limit as x goes to -3 from the right. Okay, so the limit as x goes to -3 from the right of f of x, if we are on the number line and we are approaching -3 from the right, then those numbers would be bigger than -3, right, on the number line. And so therefore we would be using this formula here to compute the limit. Okay. All right, so the limit as x goes to -3 from the right of that function there. Again, we can just substitute in. It's a polynomial, and so we would get that expression, simplify it out, and we wind up with -3 also there. Okay. So we computed the limit as x goes to -3 from the left, and we got -3. We computed the limit as x goes to -3 from the right. We also got -3. So both of the one-sided limits were equal to -3. The two-sided limit has no choice, right, but to be -3. So the limit as x goes to -3 of f of x is equal to -3. So condition 2, right, for continuity is satisfied. Yes, the two-sided limit does exist. It's equal to -3. So therefore we would move on to condition 3. In condition 3, we want to know, is f of -3 equal to the limit as x goes to -3 of f of x? So from part 1 we found out that f of -3 was equal to 4. From part 2, we found out that the limit as x goes to -3 of f of x was -3, and they are obviously not equal to each other. So therefore, condition 3 is not satisfied. These two things are not equal to each other. So condition 3 fails, and if any single one of the conditions fail, the function is not continuous at that number.